So in case of patch antenna, which is made for 3.5 gigahertz, that is sub 6 gigahertz application. So in that case, if you want to see the far field, we will have to follow the same steps. So in this way, but for this, what I'll do, that I will run one more time the simulation. Okay, first thing, and then second thing is that in case of far field, in the output plan under the EM setup, whatever you have defined the EM setup, so under this frequency plan, we are having one more option, that is output plan. In the output plan, you have to come down and you have to look for this option, that is save currents for. And in this save currents for, you have to mention this all generated frequencies. So, and whatever the currents will generate, it will save for each of the frequency further. Another important thing is that while defining the frequency plan, you have to add two things, that is adaptive 1 to 5 and single, that is 3.5. Now single, why we have applied? Because it is our center frequency, or you can say the frequency of operation. So in that case, we have defined this one more frequency as a single one frequency, so that we can see the exact parameters like gain, directivity, and all at that 3.5 gigahertz frequency. Otherwise, you will not able to see the surface current distribution at this particular frequency because of this sampling. Because in between 1 to 5, maybe the sample will come at exactly 3.5, or it can be 3.55 as well. Okay, so in this way, you have to keep in mind at this simple step. Okay, so what I'll do, I'll try to simulate this, and I'll again simulate this one. Once it will simulate, it will by default showcase your S11, which is already coming out to be 15 dB. Anyway, if I'll delete this, and I do not require this, what I'll do, I'll directly go for your far field distribution. So under this far field distribution, you can go with this far field option. Okay, so once you will click on it, within few minutes or within few seconds, you can say, it will generate your surface current as well as the demonstration for your far field. Anyway, as I said, we'll not able to go a full far field for this antenna. Under the solution setup, I'll select the 3.5 frequency. As you can see here, 3.66 is also there. Okay, so since we have selected the 3.5 gigahertz as a single one, that's why it is providing this exact frequency as a surface current distribution. Okay, under this plot properties, you can go with the animate and dB scale as well, and go for far fields, and then click on antenna parameters at 3.5 gigahertz. Okay, so the directivity is 6.7 dBi and gain is 4.1 dBi. Radiation efficiency is 55%, or you can say around the 56%. Since we are using the FR4 substrate, which is quite lossy substrate, so that's why the radiation efficiency will also reduce somewhat. Okay, so this is the more or less our key parameters in case of the patch antenna designed for sub 6 gigahertz application, or you can say sub 6 gigahertz frequency. Okay, so in this way, one few parameters are also mentioned, like what is the input power, what is the radiated power. So 0.0023 was the input power, and radiated power is 0.001, like around that is why around 50-55%. Okay, so that is all about your surface current distribution. You can plot this image as well by simply copying this image. Okay, or try to stop this animation at some certain point, and you can even take a screenshot of this, take a snap, and you can use it in your case of your research paper, or in case of your report as well. Okay. I hope you understood this concept. As I said, don't forget to remember those two steps. First is in under the frequency plan, you have to go for adaptive as well as single one. And at single one, whatever is your center frequency, that you have to select first thing. Second thing is that under the output plan option, you have to go for the save currents for all generated frequencies, so that you will able to see the surface current distribution for all the frequencies. Suppose at 4.8 we can see the surface current distribution, but we cannot see the surface current distribution at 4.9 or 4.7, like that. So that's why it's necessary to go for that. Okay, so I hope you understood how to calculate the S11 and all, and how to go for the designing part, as well as how to generate this surface current, and how to look for your key parameters required for that. Okay, so in this way, if you have attended our previous course as well, which was in live mode, so you can even compare your antennas with some 2-3 softwares and which use different computational electromagnetics techniques. One is using FEM, one is using FTDD, one is using MOM. And so in this way you will be able to analyze all your antennas in these ways. Okay, so I hope you understood this and you enjoyed this session. Thanks a lot for attending this and watching this session. Thanks a lot.